Now I am discussing one of the question in the A-level Cambridge paper. Question number 4. Children, you should be able to understand this question is directly relevant to mechanics. That is M1 paper. Why it is important? Mechanics. Actually, in practical situation, especially vehicles, they are moving power, the speed. So actually main things in a vehicle, especially by learning this type of problem, practically we can apply to perform of the vehicle. Now I would like to discuss the question. Children, I will read it out, that question. A lorry of mass 25,000 kilograms travels along a straight horizontal road. Full stop. There is a constant force of 3000 Newton resisting the motion. Now Roman numeral 1. What is the question? Says, find the power required to maintain the constant speed of 30 meters per second. Now, especially in this lesson, we are dealing with the formulas. Then to find the power, we can apply the formula. What is the formula? P equals to F multiplied by V. That is, power equals force multiplied by speed. Then very easy. Now you know what is the constant force? 3000 Newton. 3000 Newton. What is the velocity given? 30 meters per second. Then we can multiply together. Then 3000 multiplied by 30, 90,000 joules. Actually power coming in joules. That is the answer for Roman numeral 1. Then Roman numeral 2 question. What it says? The lorry comes to a straight hill, inclined at 2 degrees to the horizontal. Full stop. The driver switch off the engine of the lorry at point A, which is at the foot of the hill. Full stop. Point B is further up hill. Full stop. The speed of a lorry at A and B are 30 meters per second and 20 meters per second respectively. The resistance force is still 3000 Newton. The resistance force 3000 Newton. What is the question? Use an energy method to find the height of V above the level of A. Now, especially for this type of problem, we should draw free body diagram to solve the problem. Otherwise, we can't solve this problem, right? Now you can see. Now this is the slope actually. Now this actually slope inclined to 2 degrees horizontally, then 2 degrees horizontally this way, right? Then you can see now at starting point of this right hill. Now what is the speed of this lorry? 30 meters per second. It climbs up to the top. What is the speed of the vehicle? 25 meters per second. Now we can mark the speed like this, right? This is free body diagram. Now weight also acts vertically. Now what is the weight of this vehicle? 25,000 kilograms. Downward forces. Downward it acts. Now I also mark here. Now you can see, if you take this vehicle, now I took the vehicle like square shape figure, very easy to work it out. Now you can see, now the angle between vertical to the plane and the, the weight acts downwards, then vertically, the angle between this, now vertical to the plane and the downward, that's vertical, 2 degrees. So therefore this angle 2 degrees, this also 2 degrees, this also 2 degrees. Now I have taken the distance, actually the length of this slope as d. Okay, the height of the slope as h. Okay children. Now this is the free body diagram. Now you can see the resistance force actually opposite to the moving direction, 3000 Newton. Right? Then I mark all the right forces and the speed here. Now first of all, actually there are 3 types of energies act on this vehicle. What are the actually energies? Now kinetic energy, potential energy, and energy due to work done. Now you can see this component, actually the resistance force, it acts work done, right? Then work done actually can be resolved vertically and horizontally. Now actually vertically resolved, work done, you can see what is this vertical. What is the vertical force? F sine 2 degrees, then multiplied by what is the actually in terms of the d and angle, what is the height of this? Then it moves from here to there, then d sine 2, then we can multiply together, actually we can find the work done vertically. Then due to the other component, right, actually horizontal component work, actually what is the force? F cos 2 degrees this way. Now this is 2, this is 90 minus 2 degrees, this is 2 degrees, right? Then F cos 2 degrees multiplied by, now you can see, you can find this length from here to there. Now what, then in terms of d and angle 2 degrees, then d cos 2. Now what is the total work done by this lorry? Actually sum of these, right, vertical work done and the horizontal work done, actually when you simplify, Fd sine 2 degrees multiply sine 2 degrees, then Fd sine square 2 degrees plus this Fd cos square 2 degrees. Actually we can take Fd out, then sine square 2 degrees plus cos square 2 degrees. Then what is the component of this? Now trigonometry, you know, sum of these sine square 2 degrees plus cos square 2 degrees equals 1. Then FD. Actually, due to the resistance force, how much is the work done? Force multiplied by the length of this, actually the length of this this hill, the D, so FD, right? Only by using this can't we solve this problem. Now you know energy conservation law. Energy conservation law. Actually, according to that energy conservation law, energy cannot be destroyed or created. Right? Energy cannot be created or destroyed. So therefore initial energy equals final energy. But we can apply, right, initial energy at A. Right? What is the final energy? The final energy at B. So both energies should be equal. So therefore we can write down what is the kinetic energy here at the beginning at A, and potential energy at the beginning at energy due to the work done at the beginning, right? So therefore final kinetic energy plus final potential energy, final energy due to work done, right? Add together, right? Kinetic energy plus potential energy plus energy due to work done initially, then finally kinetic energy plus potential energy plus work done, finally work done. Then you should be able to understand at the beginning there is no potential energy because there is no height actually goes up, no. Then initial work done is no, because it does not move any distance. So therefore this component, potential energy and work done, the energy, that component becomes 0. So only thing is what is the kinetic energy at the beginning. Kinetic energy. Now what is the kinetic energy? You know what is the formula? Half mu square. So what is the half into what is the weight mass of the lorry? 25,000. So what is the speed of this vehicle at the beginning? 30, then 30 to the power 2. Then finally, that is very, very important. Finally, you can see, finally, what is the kinetic energy? Because due to the final speed of 25 meters per second, then half into 25,000 multiplied by 25 to the power 2 plus. Now, what is the potential energy? Potential energy mgh, no? Then mass of the vehicle 25,000. Then you know gravitational force. What is the 10? What is the height? It has goes up h. Then h. Right? That is the h. Right? Then plus work done. Actually, total work done by this lorry, FD already we have found. Now you know what is the force. Now already we know what is the force. 3,000 multiplied by D, this length, the length of the actually hill, right? D. Actually, by using the trigonometry, now you can write down, we can write down D in terms of h and this angle. Now you can sine 2 degrees equals, now you know, h divided by D. Then you can find actually D equals h divided by sine 2. So that you can see these components actually. Now addition of these energies on right side you know actually kinetic energy finally and potential energy, right? Kinetic energy plus potential energy plus the energy due to work done. So 3000 multiplied by D is, you know, h divided by sine 2. Children, now we can simplify. Actually we can cut it 2 zeros, 2 zeros, 2 zeros from these components, this kinetic part, then the kinetic part finally, you potential energy, when you can see cut 2 zeros, then you know work done, then 2 zeros we can cut. Then if you simplify, what is this answer for this? Half into 250 multiplied by 900. So what is that? 112,500 equals, if we simplify this final kinetic energy, 78,125 plus then this component 2,500h plus, when we simplify this component, actually 3000 multiplied by h over sine 2 degrees, 862h. Okay, then we can take 78,125 to the left, then we can subtract 112,500 minus 78,125, then 34,375 comes. Then we can add 2,500h plus 862, then 3,362h, then 34,375 divided by 3,362, then what is the height? H can be taken as 10.22 meters. This is the way to actually work out this problem. Actually then height, what is the height of this, actually height of this hill, right, at the level of the from the ground, 10.22 meters. So that is the answer. Actually this type of problem can be solved very easily by using energy conservation law.